Okay, before I start, I just want to mention there will be a link and a QR code at the end of this talk to the slides. So if I rush through anything too quickly and you want screenshots, you can grab it at the end. I'd like to start this afternoon with a scenario, perhaps something familiar to you. You're tasked with updating a front end of a web application. This is not a living project or a greenfield one. Instead, it's a legacy project, one that's been around the block a few times. I think it's PHP 5, and the version of Gulp doesn't work with the latest version of Node.js. The last commit was in 2014, and your task is to add a button to the form that will auto-populate it with data from an API. As you set up your environment, you look over the front-end scripting. It's thankfully all JavaScript, no CoffeeScript in here, but no TypeScript either. You'd prefer it to be TypeScript, but it's not. And your task is not to refactor the entire project's build process just so you can use TypeScript. You're just going to add a button to a form. And that's the point I want to make today. There's a lot of JavaScript out there, and I mean a lot of JavaScript. Now, if you attended this conference last year, there was a wonderful talk by Eamon Boyle from Gearset about how they incrementally added TypeScript to their code base, how they took on that challenge, and how long it took them to get there. For a living project, I think that's the right choice. But think back to that scenario I just gave you. Maybe you know of some projects like that. Are they worth the time to migrate to TypeScript? And why would you want to migrate to TypeScript? Because developers love the types that TypeScript provides. They love the squiggly lines that tell them when they've made a mistake. They love the autocomplete that tells them what properties are available on an object. They love the types, give them documentation on the code base, and they love the static analysis that can catch bugs before they happen. What they might not love, however, is the build process. In workshopping this talk, it was suggested to me to call it "Friends Don't Let Friends Use Build Tools." But I think that's a little extreme. What I want to show you today is how to get the types, the squiggly lines, the autocomplete, the documentation, and the static analysis without the build process. I want to show you how to get TypeScript without TypeScript. And I can do that through the use of comments in your existing JavaScript code base, even one that's a decade old. But first, a little trip through history. The year is 1999. The third edition of ECMAScript Standard is being finalized, and the committee is already looking ahead to the fourth edition. In this memo, they outline some of the features they'd like to see in the fourth edition, and one of those features in that first bullet point there is types. That all sounds promising, but if we look up the specification version and scroll down to the fourth edition, it's missing. Now, if I wanted to discuss what happened here, I'd need more time than I have today, but the abridged history can be summed up as Microsoft said no. If you are interested and maybe want to read a bit more of the history, there's a white paper online called JavaScript, the first 20 years that you can read through in your own time. It's rare that a white paper is a page turner, but if you don't know the history, without spoilers, there's more action in there than a Korean K-drama. Now you know. Types are not a new idea for JavaScript, and yet somehow Python, PHP, and plain old CSS got types before JavaScript. And what do those types look like? Well, for a rejected standard, they're not as crazy as you may think. And if we adjust them slightly, we can see how close they are to TypeScript too. There's a brief blog post detailing some of these features in the link below if you want to know more. We didn't get this future in 1999, and the nature of JavaScript language means we might never get it as implemented in the fourth edition, but change is on the horizon. Fast forward to today, and the team behind TypeScript have submitted a proposal to have most of the type annotations in TypeScript work in JavaScript natively. The process takes time. This is not going to be something we're going to see in the near future, but it is the future that we were promised 20 years ago. The proposal also can't be a carbon copy of TypeScript. It needs some minor changes to syntax, such as generics, as they use angle brackets to capture the generic value. That's a problem for JavaScript since those symbols are already in use. Obstacles like this, they need to be resolved first. Unless, of course, you want to let developers, like this individual here, who came up with an innovative solution to Golang's lack of generics through the use of the Canadian Aboriginal syllabics block. That's the past and the future. What about in the meantime and in between time? What can we do today? That's where JSDoc comes into the picture. Inspired by JavaDoc and tracing its heritage back to the 90s, JSDoc lets you document your code. If you've ever used JavaDoc, it'll feel like a dialect of it. Another child of JavaDoc is PHPDoc for the PHP language. Before there was a language level solution to type declarations, PHPDoc filled that void along with doc blocks. So if you're familiar with PHPDoc, this is the direction that JSDocs and JavaScript is heading. Comments today, language features tomorrow. As for how we're going to get from comments to IDE integration, that's where TypeScript enters the picture. The TypeScript language server that provides all the features you know and love about TypeScript has also quietly supported a limited subset of JSDoc, specifically of the Google closure syntax variety. This has allowed TypeScript to also check JavaScript files and even attempt to infer the types to maintain that developer experience. This is important because of two events that have happened in the last 2 years. First up, Google finally archived the Closure library after announcing it last year. The Closure compiler does live on internally at Google, but for those outside of Google, this left the TypeScript language server as the only JSDoc type checker that is widely supported today. Which brings us to the second event. Acknowledging this, the TypeScript development team have started to add new features to TypeScript that are JSDoc specific, which you can see in the release notes for TypeScript over the last 2 years. Buried in the release notes are new features like the new JSDoc import tag, the new satisfies tags. There's more examples, but we're on the clock. Now that you're caught up, let's see some code examples of what you can do in JSDoc in your JavaScript code base. By default, TypeScript will not evaluate JSDoc, since that's a default behavior that you expect in your IDE. To enable it, you need to use a directive such as @tscheck, and that will enable type checking in that file. Alternatively, if you want to enable it for every file in the project, you can throw a tsconfig into your working directory. And the last option, enable it globally in your VS Code settings. With that done, we can get type checking with JSDoc. If you have type signatures in another file, you can import them just like this in TypeScript. And just like this in JSDoc. It's simple, yet familiar. To define an object in TypeScript, you can use an interface or a type. And with JSDoc, you can just use a type def, just like that. Type declarations in TypeScript can't be extended, but interfaces can. To extend an object in JSDoc, use the same syntax as you would for merging two types defined using the type keyword in TypeScript, through the use of an intersection ampersand, just like that. In TypeScript, you can set the type of a variable by putting the type after the variable name. And in JSDoc, you can do the same by moving that type to the comment before it. Sometimes you want a deeply immutable object. If you want to do that, you can use asConst syntax in TypeScript. And the type const in JSDoc. The syntax for functions is super simple. You just move the type annotations up into the comments. JavaScript doesn't have function overloading, but TypeScript does. And with the overload signature in JSDoc, you can provide multiple function signatures for a single function. Sometimes you don't need a function declaration, but a function definition. In those cases, you can use the callback tag in JSDoc to create a type of a function to use elsewhere. If you ever need to bind a function to another object and you want type safety for that, you can use the @this tag in JSDoc, although you're more likely to use classes. And every access modifier prefix in TypeScript is also available in JSDoc. Classes in TypeScript can implement interfaces. And you can too in JSDoc with the implements tag. That's just some of the basics. Now let's see some of the more intermediate examples. We can cast types in TypeScript with the as keyword, and likewise, if we wrap a variable in a typecast in JSDoc, we can do that too. Quite a few modifiers here to run through. Have a quick look at this definition. We have two optional numbers defined in two ways, a nullable string, a nullable optional string, a union type, and a nested object. Now let's see how that looks in JSDoc. The optional number can be defined with a shorthand equal operator syntax from Closure, or with the square bracket syntax familiar to C#. The nullable string can also be defined with the Closure shorthand question mark. The union works just like TypeScript, and the nested object allows dot notation to define the nested properties. Now this is a little advanced. Type guards let you narrow a type. These work great in conditional statements. The syntax works just as well with JSDoc as it works in TypeScript, and it looks like this. I've also included an assert type guard because if type guards were esoteric, asserts are even more so, and yet here they are working in JSDoc too. Generics are the super secret weapon of TypeScript, and JSDoc can have them too. Here we have a generic that takes anything, and just like that, it's now generic in JSDoc too. Additionally, we can provide a base type and a default type to a generic. If we do not provide a type when we use it, it'll use the default, and any type we provide must be a subset of that type. And in JSDoc, it works just like that. Lastly, I want to show you some comment syntax and what you can do with it. The syntax works in TypeScript and JavaScript comments. You can use the link syntax to provide a link to a specific type in the comments for easier navigation. And there's a throw statement. While TypeScript will not warn you about not catching this error, you can include it to help document your code. And there's linter rules that can enforce this as well. Some quick additional examples also include linking to variables in the comments, and below that we have a link to an external image. Hiding images used to be quite a fun little Easter egg, and I feel we've forgotten how to do that. Let me just... Going to work for me? Alas, it's not. Ladies and gentlemen, this is why we prepare these things in advance. It used to show up in some unexpected places. Here we have Guy Fieri of Flavortown in somehow finding his way into Babel's source code. What about what's next? What new features are in the pipeline? The non-null tag lets you omit the type from any nullish value. You can do that right now with TypeScript using an exclamation mark after the value. Right now, with JSDoc, you need to cast it to a value, but coming soon, it'll be as straightforward as this. Sometimes you want to pass a generic to a function. With TypeScript, you can do it like this, but with JSDoc right now, you need to cast the parameter. But soon, it'll work like this. That's just a small tour of the JSDoc syntax. If I've intrigued you enough to give this a shot, a comprehensive guide's out there on Joshua's Doc's cheat sheet for exploring this world a bit more. So there you go. You might not need TypeScript. You can get the types, the squiggly lines, the autocomplete, and the documentation, and the static analysis. Without the build process, you can get TypeScript without TypeScript. And, as JSDocs just comment, I'll leave you with the words of German mathematician Karl Weierstrass, whose wisdom has found its way into many comments and expresses exactly why you should type your JavaScript. Thank you.